So, my dear students, uh, let us talk about friction. Okay, I know yesterday we had already had a little discussion about friction, but again from the beginning, okay, let us discuss today. So, the first portion will be simply a revision of the earlier earlier days lecture. So, we had discussed that in some machines and processes, we observed that it is required to minimize the friction. Okay, in order to run the machine or in order to run that process, if we minimize the friction, it is beneficial for us. What was the examples? Examples were gears, okay, or some threads, that means screw joints. So in those cases, we intend to minimize the friction. In the other hand, we have some machines and some processes where we want to maximize the friction, such as brakes. So brakes basically dependent on the frictional force. Clutches. So in this type of processes or machines, our intention is to maximize the friction. So in some cases we want to minimize, in some cases we want to maximize, no matter, but we have to be concerned about this term friction, because in some other cases also, suppose uh, when a vehicle is running, if we want to stop it, or even if you want to start it, so to stop a vehicle we require braking system, and even for starting a vehicle, what do we require? We require a force in the forward direction, which is nothing but frictional resistance. Okay, that means the Newton's reaction force. According to third law of Newton, some reaction force is generated. So if in the floor no friction is there, think whether this reaction force was possible. Obviously the reaction force was not possible. So that is why friction is very important, whether you want to minimize it or you want to maximize it. Broadly, we had classified friction into three categories. First category is dry friction. What is dry friction? Now when two solids are in contact and they are not lubricated, that means no oil film is there between these two surfaces, then dry friction occurs. So a slide, your tendency to slide, in those cases dry friction we can observe. Second type of friction is fluid friction. So it was in the fluid flow. So when fluid flows, we know that at different layers you will get different velocity. So some layer is having more velocity than others. So which is having a larger velocity, that will try to glide over the adjacent layer. Due to that, some restriction will be offered by the second layer. So this type of restrictions are basically frictional force, and we term it as fluid friction. Now we know it very well from the concept of fluid mechanics that this fluid friction is nothing but it is something offered by the viscosity of the fluid, and it is dependent on the nature of the fluid. In the third category, we have internal friction. So internal friction occurs mainly in the solid materials, specifically when they are subjected to cyclical loading. So what is cyclical loading? Cyclical loading means periodically you are giving tension and compression to a material. Then it is called cyclical loading. So when a material is subject to tension, what will happen? It will be elongated, and when it is subject to compression, it will again compressed. So elongation and compression, if it is repeated cyclically, now it will depend on the material. If the material is highly elastic material, then there will be no internal resistance, and due to that, original shape and size of the material will be regained accurately. Accuracy level will be higher, okay, of regaining the size and shape of the material, which we can observe in case of elastic material. Now if the material's elasticity is not very good, then some amount of plastic deformation will be there, and that amount of plastic deformation cannot be recovered. Okay, so that is that resistance against the recovery of the shape and size, that is basically the solid internal friction. So in case of plasticity under cyclic loading, this factor of internal friction is very much important. Now if we concentrate on the dry friction, then we need to study about two type of friction. Okay, dry friction, which is dynamic. Dynamic means the body is not in static condition, the body is movable. So in that case, we have two types of friction. One is sliding friction and other is rolling friction. What is sliding friction? Suppose one body, after the application of force, slides over another body. So that is one type of interaction between two contact surfaces. In this type of cases, friction offered by one surface to another, we call it sliding friction. And in the second case, we call it rolling friction. What is second case? Second case is, think about a wheel. When a wheel is rotating, it is not having a sliding motion. Okay, so this type of motion is rolling motion. Now when a body is not sliding, so in case of rolling, whether there is any friction, in case of rolling, now obviously there will be some friction. If friction is not there, then how the wheel is moving in the forward direction? Otherwise it will slip in the same position, it will continuously slip. So when it is moving in the forward direction, that means frictional force is there, but this frictional force is much lesser than the sliding friction. Okay, that is why wheels are discovered. Okay, in order to minimize the friction. If you slide a vehicle, you cannot do justice to your energy, because maximum amount of energy will be wasted. But in case of rolling, this energy wastage due to friction is very less. So you have to remember that in case of rolling friction, frictional force is much lesser than the sliding friction. Then we will study about the mechanism of dry friction. So in order to study that, firstly we have assumed that a body, a block, this is a block, so this is resting, on the uh, floor. Okay, this gray colored floor you can see, and this is the blue colored body, and we apply an external force in a particular direction, that is P. Okay, so as long as the body is in equilibrium, so what we can do, we can directly find out the magnitude of the unknown forces from the equilibrium conditions. So let us draw the free body diagram. So this is the free body diagram. Okay, this body we have drawn here. So one weight is acting in the vertical direction, vertically downwards direction. So some reaction force will generate. It will be supplied by this floor. So that is N. Okay. Reaction in the normal direction of the contacting surface, that is why normal N. And the force is applied in the right hand side, in the right direction. So obviously some restriction to this force will be generated, that will be in the left direction. So this is F, in the opposite direction to the tendency of the motion. Now from this free body diagram we can tell that N is nothing but equal to mg, because there is no other force in the vertical direction. So N is equal to mg, and also we can tell F is equal to P, because there is no other force in the horizontal direction. Now what is the physical significance, or what is the mechanism of this? For that you need to come to this magnified view. Okay, this figure you can see. So in this figure you are getting a magnified view. So two surfaces are in contact with each other. So this blue colored surface and this gray colored surface. Now though in the natural view, in our eyes we can see that these surfaces are smooth, but in the magnified view what we will see, that these surfaces are not smooth, but they are having roughnesses, and due to the roughness, what is forming here, some peaks and valleys are forming. These are valleys and these are peaks. So some peaks and valleys are formed in this wavy surface. And also another thing we need to observe, that is the contact area is much lesser than the geometrical contact area due to this peaks and valleys. Hope you all appreciate this conclusion from the geometry. Okay, as the contact as the physical contact is happening on only at the this locking zones. Okay, only this probably in these peaks. So the contact area is much lesser than the actual geometrical contact area. Now in this contact area, the reaction force will be generated in some direction. We don't know what is the angle with the reaction force. In the coordinate system, we had taken two coordinate. One is tangential direction, that is small t, and other is normal direction, that is small n. Now this r, suppose r1, this r1 will have a component in the tangential direction. Okay, what is this component? This r1 will have a component in the tangential direction and also will have a component in the normal direction. So in the tangential direction, suppose this is t1, and in the normal direction, suppose this is n1. In similar manner, r2 will also have a component in this direction and also in this direction. R3 will also have a component in this direction, tangential direction, also will have a component in normal direction. So it will be N3 and it will be T3, in the earlier case T2 and T3. Hope you understand. So if you sum up all the forces in the tangential direction, T1 plus T2 plus T3, okay, plus dot dot up to n number of turns, okay, this will be T3, I'm sorry, it will be T3. So if you add up, if you sum up all the tangential force, what you will get? You will get this F. And if you sum up all the normal force, so you will get capital N. Okay, so capital N is the summation of all small n's 1 to n, and capital F is the summation of all t 1 to n. So what we see that the contact area is not playing any role in the total amount of frictional force F. Rather, it is depending on the nature of the contact surface. So the nature of the contact surface is the only thing which will determine that how much amount of force will be generated. Now in this peaks and valleys, the force is not only generated through the locking of the mating surfaces, but also hope you will understand that due to weight of this blue colored body over this gray colored body, some deformation, localized deformation will be there. So that localized deformation will do what? It will flatten the surface locally. So due to this flattening, the area will increase locally. So that is also having a role. Sometimes temperature may be increased due to this rubbing, or we are trying to slide a surface over another. Due to that, the temperature may increase locally. That increment in the temperature may also play a vital role. Okay, in some cases, adhesive force may play something. Also, though we are observing it that the surface is properly dry, but some dirt may be there. Okay. So some very thin oil film may be there, which we have not intentionally given, but maybe due to the use of that particular machine element, there was some oil film. So that oil film may also take a part in the friction. And also attraction and force between the atoms of these two material. That may also play a vital role. So there are many things which are playing role here, but contact area is not having any particular role in this dry friction. Now, till the point where the motion is impending, up to that point we know if force F is 0, obviously if force P is 0, obviously the frictional force will be 0, because from the equilibrium condition F is equal to P. So till the point of impending motion, this relation will continue. F is equal to P. So a line with 45-degree inclination with the x-axis you can observe until this impending motion situation, and this friction we call as static friction. But just after the impending motion, that means when the body when the body start to move over the other body, so that time there is no change in the P applied. Okay, there is very minimum amount of change in the applied, but then also the body moves. So what is happening? What is the factor which is changing? The friction is being reduced. Okay, so from the static zone, when it is moving to kinematic zone, so friction is less. So P is higher than F. That is why it start moving. Okay, and gradually, when the body will gain very high velocity, after that we can see that this frictional force will be decreased slightly. Otherwise, it is more or less constant. Okay, so you know that this is the range of static friction. This is the range of um, kinetic friction. In this range, you can find the frictional force from the laws of equilibrium, from the equations of equilibrium. Okay, and in this region, the kinetic friction is constant, but at the impending motion, okay, so the point where you get maximum friction, or we call it limiting friction, so that maximum friction is proportional to the normal reaction. From different experiment of different surfaces, we can get this relation with the friction and the normal reaction. So F max is proportional to N. So in order to convert it into equation, we need some proportionality constant. That proportionality constant is here mu s. That is coefficient of static friction. Now from the discussion, what we can conclude. So that can be represented by the laws of static friction. So 5 laws we will tell in order to conclude the discussion. First law is telling that force of friction always acts in a direction opposite to that in which the body tends to move. Okay, obviously we appreciate it. If the force of friction would have been absent. Secondly, the magnitude of the force of friction is equal to force which tends to move the body. So in magnitude also it is equal. Okay. The third point, we say that the magnitude of the limiting friction bears a constant ratio with the normal reaction. That also we had told in the previous slide. Okay, so this is basically n. So f by n is constant. Okay, or that constant is equal to mu s, and the force of friction is independent of the area of contact between the two surfaces. So fourth point also we can explain why it is independent of the area of contact. Just we had explained from the magnified view. And number 5, the force of friction depends upon the roughness of the surface. Obviously the roughness is the only thing which is playing role, okay, along with some other uncertainties also. So this 5 statement is the laws of static friction. Next we will move to kinetic friction. What is that? Just after the limiting friction, slippage occurs. Okay, one body is start to move over the another body. So that time the friction offered by that body, we call it kinetic friction. So kinetic friction, from the graph we can tell, okay, that kinetic friction is lesser than the static friction. But whether it is having some relation with normal reaction or not, yes, this kinetic friction is also having a proportional relation with the normal. Okay, so Fk, kinetic friction, is proportional to n, or if we apply a constant of proportionality, so Fk is equal to mu k into n, where mu k is the coefficient of kinetic friction. Now what the thing you can say from this equation? So Fs, static friction, is greater than Fk. So obviously n is not changing for the same case where the body starts moving from the rest, but mu k will also change. So mu k is also lesser than mu s. So coefficient of kinetic friction is also lesser than coefficient of static friction. Next we will talk about friction angle. So what we can see from this magnified view, that if the roughness increases, this R will become, this angle with R and N will become higher. Okay, that means it will move in the tangential direction more, and tangential component of the reaction will increase. So that means this angle between N and R, normal reaction and net reaction force, this angle alpha, this is an identification of the surface roughness. Somehow it is representing amount of surface roughness of the contacting surfaces. So this angle, it is used to represent the quality of the surface. So from the geometry, so if this side is f, so this side is also f. So from this triangle, what we can see, the tan alpha is equal to f by n. You can easily tell it. Now, as the f will increase, this tan alpha value will also be increased, and alpha value will also be increased. Okay, now it will increase, and it will reach a certain level. That is the maximum value of f. That is the limiting value of friction. So there, f is equal to f max. So that time, this alpha will also reach its maximum value. That is phi s. That is friction angle. The s is representing static. Okay, so friction angle in case of static friction is holding this equation. So tan mu s, tan phi s, that is equal to f max by n. Okay, and f max by n we know that is nothing but mu s. From the relation we have already told that f max by s is equals to nothing but mu s. So tan phi s is nothing but mu s. That is the expression of friction angle, or we can tell friction angle phi s is equal to tan inverse mu s. Next, when slippage is occurring, so in that case, the alpha, angle alpha, okay, that also have some value, certain value, okay, because the Fk, kinetic friction, is almost constant. So Fk by n, okay, that will become tan alpha. So from that relation we can find out, or we can tell that this angle is phi suffix k, that means friction angle for kinetic case. Okay, then we can write down this equation, tan phi k is equal to mu k. Okay, now if you represent these angles by cone of friction, then what will happen? So what is the physical meaning of cone of friction? So we know this is the normal reaction. Okay, we know this is angle of, this is the frictional force, and we know this is resultant R. This is F and this is N. So this three is constituting a triangle. Now if you revolve this triangle with respect to this axis, okay, N, if you revolve it by 360 degree, what will happen? Cone will be generated. If you revolve this triangle, a cone will be generated. So in case of static friction, this is the cone of static friction, in which R is the generator. Okay, this out in the outside surface, R is lying. So in case of limiting friction, R is just at the surface. But in case where the case is static, but the motion is not impending, so then R will be inside this cone. Okay, it cannot go outside the cone. In any condition, R cannot go outside. Okay, as the friction force decreases, so this value as it decreases, R will come closer and closer to N. Okay, so in any position R cannot go outside. Next, when from static case it goes to dynamic case, then what happens? Then the triangle changes, size of the triangle changes, Okay, so F is static F. So if it is Fk, then it will decrease obviously. So the cone of kinetic friction is also having a lesser value of this apex angle. Okay, so earlier it was this side mu s, this side mu s, so 2 mu s. Now this time this is 2 mu k, which is lesser than 2 mu s. Okay, and this r at that time it will remain on the inclined surface of this kinetic friction cone. Okay. And when velocity increases very high level, that time the r may become inside this cone. Okay, so rough surfaces are more likely to have larger angles between the reaction and the in direction than a smoother surface. We have already told. But thus a pair of mating surfaces, a friction coefficient reflects the roughness, which is a geometric property of the surface. Okay, we have already appreciated in our previous slide. And with this geometric model of friction, we describe mating surfaces as smooth when the friction forces they can support are negligibly small. Okay, so when this is negligibly small, okay, it cannot be zero anytime. So when it is negligibly small, that time what happens? That times r is very close to n, so r is near about n. Okay, roughly we can tell r equals to n. So that time surfaces are smooth. Hope you remember that in the free body diagram for smooth surfaces, the F was 0, so reaction force was n, normal reaction. Now, what are the factors which is affecting friction? So, if we further experiment on this, okay, so beyond the magnified view of the surfaces, we can take different contacting surfaces. Then we can say that the true contact area, okay, which is achieved from the geometrical contact. Okay, that means the projected contact. Geometrical contact is projected contact, and true contact area. True contact area is smaller than the projected value. Okay, due to this, and why this is happening? Now we know that it is due to the peaks of the contacting surfaces, irregularities that support the load of the body. Even relatively small normal loads result high stresses at the contact point. Okay, when the normal load is very less, then also the stresses become high because it is localized. Na? So it will depend on how much area is there. You know that stress is equal to load by area. So if area is very less there, which is depending on the surface type, so then the stress become very high. Okay, as the normal force increases, the true contact area also increases. Okay, so normal force, as the normal force will increase, what will happen? Due to the stresses, okay, the material will undergo yielding, crushing, tearing at the point of contact. Okay, and due to that, the waviness it will become less. It will become flattened locally. So due to that, the area will increase. The comprehensive theory of dry friction must go beyond the mechanical explanation presented. For example, there is evidence that molecular attraction have an important cause of friction under the condition. So it is not under mechanical explanation. Okay, the molecular attraction force that is playing some role in the friction, that is beyond mechanical explanation. And some other forces are there that may also generate some cause to increase the friction, like local temperature increase, adhesion in contact, the presence of thin surfaces of oxides. Okay, thin films of oxide may be there. Suppose iron oxide that may form, or any other layer may form. Oil film may be there, dirt film may be there, or any other substance that is also having some role in the friction. So these are basically uncertainties. Now, how many types of friction problems are there? So let us find out how many types of frictional problems are there, so that when we see a problem, we can identify what to do. So first type is where it is condition of impending motion. It is known to exist. Okay, we know very well that it is case of impending motion. So that time what we can do? That time we can directly put this relation F max equals to mu s into n. Okay, because it is a law of impending motion, law of friction in case of impending motion. So we can directly put, and we can calculate the value of F max if it is unknown. Okay, or if F max is given, n is given, we can find out mu s. Okay, so this way we can proceed. Otherwise, okay, this was the first case. Otherwise, let us move to second case. In this type of problems, the condition of whether it is the condition of impending motion or not, we don't know at all. So in order to determine the actual friction conditions, what we will do, we will first assume that it is a case of static equilibrium. Okay, so in case of static equilibrium, what do we do? What is our duty? We basically draw the free body diagram, okay, of the body in its geometry. Then we solve for the forces. Okay, in some direction, some forces will be there. We solve for the forces, and after solving this, we will try to find out the frictional force F. Okay. Then after finding out this frictional force, we will see that three possible outcomes are there. One is frictional force is less than maximum force friction, or mu s into n. Okay, if F is less than F max, then obviously it is in the static region. Okay, so that time this equation F max equals to mu s into n is not applicable there. That you have to remember. Okay, that time F is nothing but P, external force. The second case, second possible outcome may be F is exactly equal to F max, maximum friction force. So that is the case of impending motion. So that is nothing but this one, case number 1. Okay. This English numerical 1. Okay, then it will go back to that step. And third case, numerically, what may be the third case? Numerically, it may be if frictional force is greater than mu s into n, but practically it is not possible. Okay, so if practically Fs is greater than F is greater than F max, that means F is lying, this point is lying outside the cone, which is not possible. So it is not practically feasible. Then in third type of problem, we know that relative motion is there. Okay, it is known very well that relative motion between these two surfaces exists. So that time, that is a case of kinetic friction. So we will apply the law of kinetic friction at that time. directly. Okay. That is Fk is equal to mu k into n. So these are the cases. So this was today's discussion. The next class we will study, we will do some numerical problems on it. So my request to you all, please uh, do revise in your home. Okay. And what we today concluded, we concluded that we have studied today that uh, the effect of frictional force, we cannot ignore that. Okay, because sometimes it is intended and sometimes it is not intended. We also discussed that three types of frictional forces are there: dry friction, fluid friction, and internal friction. The dry friction we had classified into two categories: sliding friction and rolling friction, and we had appreciated that rolling friction is lesser than the sliding friction. Then we had studied about the mechanism of dry friction. We had seen that how the resultant forces having two components, and the tangential component is generating the frictional force and normal components are generating the normal force. How the curve, how the graph varies with the increase of external force. Okay, also we had studied about laws of friction. 5 laws we have studied. Then we had studied the law of kinetic friction. What is the equation of kinetic friction? Then we had studied about friction angles, and from friction angle how we can tell about the nature of the surface. And if we revolve the friction triangle, then the cone of friction generates. Okay, and what is the physical significance of cone of friction, that also we have discussed. Then we have discussed some factors which is affecting friction. We have seen many other uncertainties are there beside the mechanical factors. And at the end we had studied about types of friction problems. Okay, directly we had come to problems, that means how to solve a problem. So we had see that three cases are there. One case is where we clearly know uh, it is a case of static impending friction or limiting friction. Second case we clearly don't know, that time three outcome we had studied. And at the end we had a case where it is a case of kinetic friction. So that's all we have studied today. We will meet you in the next day, but before that please ask your queries. Okay, if you have any query you can ask me directly.